Good afternoon, everyone. I am Justin, the head of infrastructure at Antithesis, and I'm here to talk about how we use Rustdoc in some novel ways to help validate the security and integrity of key parts of our infrastructure. So, who's Antithesis? We are an autonomous software testing platform. We combine a deterministic hypervisor, which runs our customer software, alongside a fault injector, and we use property-based testing to evaluate it for correctness and reliability. And what this means for our infrastructure is that we have not just our own services and software running inside our cloud, but we also have copies of our customer software. And this means that the services that are running at the boundary points of our infrastructure, our web servers, our API servers, the security and integrity of those services are absolutely critical. So that means that we decided when we are reviewing and developing this software, it wasn't just enough to do kind of standard code reviews where you're trying to convince a skeptical coworker that you didn't screw this up. At the same time, when we looked into some more formal validation methods, some of the tool chain there, the ROI and the setup just wasn't quite right for us. So we decided to go with an approach that we call semi-formal proofs. And what this is it borrows some of the concepts from formal methods, but it's a little bit more of a legalistic argument than necessarily like a mathematical proof. And there are three key components. We have to clearly state the assumptions that we are making about the world. We have to state the requirements for what the software must do. And finally, and crucially, there are the obligations. What must a certain block of software do in order to meet the requirements in the world that we assume to exist? So, what does this look like in practice? So we got a sample function up there, and up at the very top, we have the obligation, basically the conclusion about what is the thing that this software is responsible for maintaining. And we also have the commit hash of the last time that this block of code was reviewed. This specific obligation actually depends on one assumption and two obligations in other parts of our code base. And you'll note that the assumption and the other obligations are all Rustdoc links. What this means is we can leverage some of the tooling that's available in Rust to build a directed graph of our proof. And by verifying the structure of this graph and parts of this graph, we can get more confidence about the overall integrity of our argument. So what are some of the things that we can do? We can detect dangling references. We can notice that when something that a function is relying on has moved, been renamed, been deleted, we can detect that that no longer exists. Also, if the text of the link itself does not match the text at the destination, that means that the function that we're depending on maybe doesn't do the thing that we think that it does anymore. And that could represent unsoundness in our logic. We can detect circular logic. We can also catalog all of the places where we are relying on a specific assumption. And so if we go back and revisit or change that assumption, we can instantly identify all of the places in this proof where we might need to go back and take a second look. And we can also, with some integration with our blame layer, go through and notice if the code itself has changed since the last time it was reviewed. And this might represent a case where the function no longer does the thing that it is obligated to do. And this kind of automated tooling is essential when you're working with a complicated project like a web server or API server. This is actually a collapsed down dependency graph. We've got each one of those boxes is a file, and within each one of those, there's anywhere between 1 and 100 different assumptions and obligations. And the visualization tooling lets us see whether or not the entire proof hangs together. So we all know that the Rust tool chain, sometimes you sit down, you go to program, and you try and get in a fight with it, and that's not really a fight that you're going to win, or at least you're not really going to enjoy that fight. But if you can find a way to leverage the tool chain and make it work for you, then it can be an incredibly powerful ally. So even something like Rustdoc can really help you. So thank you, everyone. If you have any questions, our booth is right out there. Just go to the Super Mario video screen or the regular Mario video screen. Check out our website. We have a blog where we talk about a lot of the really cool things that we can do with our technology. You can even book a demo. And if you'd like to learn more about semi-formal proofs, check out the talk that we gave at NYC Systems a few months ago. It's up on YouTube. So, thank you.